Here at Reading, we're very interested in the brain and how the brain controls the hand, how the hand then interacts with the world, and how the information comes back both through the hand itself and through what you see and what you hear. And in particular, we're interested in, if there's damage to the brain, how we can use our knowledge of these processes to allow someone who's had some sort of brain injury to get the best possible recovery.
We are currently designing complex robots which could be used in the clinic or in the hospital to provide complex therapies, complex movements for people recovering from a traumatic brain injury or a stroke.
So we're very interested in this idea of what are called haptic interfaces, where the brain and the hand is convinced that it's interacting in a real world, even though the world is entirely simulated by a computer at one end and something which is akin to a robot or a haptic interface on the other. And this is work that we've been doing with Royal Berkshire Hospital in Reading, and they've allowed us to do some clinical trials.
So this is the Gentle G robot, the first neurorehabilitation robot in the world to do full arm rehabilitation. So what the robot is able to do is to allow Jen here, who's been involved in our clinical study, to regain function of their arm. Now the robot understands what Jane is trying to do and helps her every step of the way.
Over the last week or so, the fingers have started to move. And the arms started to move, which I couldn't do before. There's lots of movement. It's helped a great deal. It's really good when you come on it. You can do. It's amazing how good it feels, because you can actually do things with that arm that you can't do anything with.
Because we can look at this process, what we can do is we can provide someone who's had a stroke an opportunity to have as much what we call errorless learning. So without making any mistakes in their movements, and allowing the robots or the haptic interfaces to assist them with their movements, the robots can actually give a very strong set of information back to the brain, so the brain can get a very good hold on exactly what it needs to do to undertake a particular movement.
If you can deliver that sort of patient enthusiasm and integrate that person into the environment which you've given them, we think that's probably the best environment in which to encourage neuroplasticity and recovery of brain cells.
There is evidence that the more movements you do, the more chances you have to regain function. So we're looking at having high-tech technologies in clinics and hospitals to work more on complex movements, and then having lower tech technology, cheaper technology in the home. And we're also looking at new technologies such as games, so people at home could actually practice movements in order to regain function more easily.
I was hit by a lorry off my push bike, and it caused me to have brain damage. To help me, it helps me remember how I was doing things, games I was playing, and the right way to do things, and using a controller as well, and you get involved in doing it. So it does help you get your movements back and remember how to do things.
We would hope in the future that we could link these complex systems in the hospital to the home systems, so that the physiotherapists can be informed of what sort of movements you are doing while you are at home. So by next time you return to the hospital, they actually know exactly how they should adjust the therapy to achieve the best results possible.
We do think that there will be opportunities to develop the work and provide it as an outpatient service, or perhaps even as a reduced size robotic system that people can take home with them and practice on the television with instructions from a physiotherapist down the telephone. So if you like tele-robotic working, that will be my own vision for the future.
What we're going to do is change people's lives, because the technologies are going to be there and available. And yes, it will have a very strong impact, because the more we can get the correct rehabilitation processes to work, the more chance the people have of recovering their movements.